Basic ear anatomy, effects of hearing loss on your brain. Before we can understand hearing loss, we must first understand the basic anatomy of the ear. The ear is made up of three parts: the external, middle, and inner ear. The outer ear includes the auricle, which is the cartilage covered by skin on both sides of the head, the auditory canal, also called the ear canal, and the eardrum, also known as the tympanic membrane. The outer part of the ear collects sound. Sound then travels through the auricle and the auditory canal, a short tube that ends at the eardrum.
This is the middle ear. The middle ear includes the eardrum, the cavity, also called the tympanic cavity, the ossicles, which are three tiny bones that are attached, known as the malleus or hammer, which is a long handle attached to the eardrum, the incus or anvil, the bridge bone between the malleus and the stapes, and the stapes or the stirrup, which is the foot plate and the smallest bone in the body.
The inner ear. The inner ear includes the oval window, the semicircular ducts, the cochlea, and the eustachian tube, which is also known as the auditory tube. The oval window connects the middle ear with the inner ear. The semicircular ducts are filled with fluid. These attach to the cochlea and nerves. They also send information on balance and head position to the brain. The cochlea is a spiral-shaped organ of hearing. It transforms sound into signals that get sent to the brain. The eustachian tube drains fluid from the middle ear into the throat, which is located behind the nose.
Now we will talk about the process of hearing and the cognitive decline that comes from hearing loss. The process of hearing starts as sound waves enter the ear canal and make the eardrum vibrate. This action moves tiny chains of bones, the ossicle, malleus, incus, and the stapes, in the middle ear. The last bone in the chain knocks on the membrane window of the cochlea and makes the fluid in the cochlea move. The fluid then triggers a response in the hearing nerve.
Hearing loss can cause daily frustration, irritability, and stress in a person's life. When senses are altered, the brain reorganizes and adjusts. Losing the ability to hear can accelerate gray matter atrophy in auditory areas of the brain. People with untreated hearing loss have less gray matter in the auditory cortex, which may begin when hearing ability declines.
Studies have found that people with untreated hearing loss have lower gray matter density of the auditory areas and less brain activity when listening to complex sentences. The brain loses its high functioning ability because the auditory area of the brain no longer receives the nerve impulses from the sounds that the ear hears. The auditory area in the temporal lobe of the brain will begin to degenerate and creates the ripple effect to the Wernicke's area of the brain, which is responsible for converting auditory information into understandable spoken language.
With any degree of hearing loss, there can be areas impacted. Individuals, specifically the older adult population, with any degree of hearing loss may suffer from social isolation, which puts them at a higher risk of accelerated cognitive decline. This could in turn impact their ADLs, also known as adult living activities, relationships with others, and their emotional state.
To avoid hearing loss, protection is key. Protecting the ability to hear with hearing aids preserves a person's perception, cognition, and how the brain processes sounds, including speech. Hearing should be tested at all ages to maintain a high-functioning brain. By using these in noisy settings, you can preserve your hearing longer and delay noise-related damage.